Okay, so the next lesson in our place value is focusing on powers of 10. We're going to have the kids be able to explain and understand how a decimal point moves in a number when you multiply by 10, basically. So today we started with what happens when you multiply 5 times 1. Well, it stays the same, and the decimal stays the same. Again, remember, we're focusing on how decimals move. When we multiply 5 times 10, the kids will already tell you, I know that it's simply a 5 and add a 0. But they've forgotten that essentially this symbol, the multiplication symbol, tells them the decimal should move right. And the 10 says we're going to move it to the right one time. So it would really look like this if they had to put it into a picture. This is where we started. Even though there's no decimal on this whole number, every whole number has one, whether it's written or not. It's always behind the ones place. So because I'm multiplying, my number is going to get larger, showing the decimal to move to the right by one place value, which is 10. So therefore, that's why that's that answer. That's why 5 times 10 is 50, and we just add a 0. So if we were to look at this, here we have our 5. Because I'm multiplying, the decimal goes to the right. I'm multiplying by 100, which has 2 zeros. It will go 2 times. 1, 2. We'll fill in the blanks with our zeros, explaining that's why it's 500. Same thing here. 5, with my decimal point already there, I'm going to move my decimal point to the right 3 times. 1, 2, 3. There's my decimal point. And that explains why. Because every time we multiply by a 10, we're gaining a place value. Ones, tens, hundreds, thousands. So we notice, first of all, when we multiply by a 10, our number is going to increase in value. And we also noticed that when we multiplied, our decimal moved to the right. So then, excuse me, if multiplying means it moves to the right, we know division is complete opposite. So we know right off the bat, if I focus on opposites, when I divide by 10, the number will decrease by tens. And again, dividing by 10 means my decimal will move opposite, which is left. So when we divide by a 1, nothing changes. When I do 5 divided by 10, I'm moving to the left 1 time. So this time, where my decimal was behind the 5, it's now going to move to the left and become 5 tenths. So you can see 5 tenths is also the same thing as 50 cents. Our number is now, the value of our 5 is decreasing. Divide means left. Here's my decimal with my whole number. And because I'm dividing by 100, 1, 2 hops, fill in my blank. Dividing to the left. Here's my 5. Decimal is behind it, but when I divide to the left 3 times. 1, 2, 3. So that's where we started today. And then we did some powers of 10. But I want to back up with you for a moment. And I want to talk with you about what powers of 10 are. So what is a power of 10? A power of 10 is simply a 10 with an exponent to show how many times the 10 is being multiplied. So if I have 10 to the first power, that means the 10 is only multiplied one time, which means 10. So if it's 10 to the second power, that means I have 10 being multiplied twice. The biggest misconception here is the students want to say 10 to the second power is 20. This does not represent 10 times 2. This 2 represents 10 being multiplied twice. So it actually equals 100. 10 to the third power is 10 being multiplied 3 times, which is 1,000. And your child should notice a pattern. The exponent matches how many zeros are behind the 1. 10 to the fourth power is 10 being multiplied 4 times. It is not 10 times 4. So here we are, 10 to the fourth power. So it's 1 with 4 zeros. 10 to the fifth power equals a 1 with 5 zeros. So that's the first thing to notice with powers of 10. Now what's going to happen is we're going to put powers of 10 in with our multiplication that we just did. So I'm going to come back to this page. So if it says 10 to the first power, that simply means I'm multiplying by 10. 5 times 10, or 5 times the 10 to the first power, is simply moving my decimal to the right because I'm multiplying one time. That's 5 times 10. So we can actually do the same exact pattern. This is where my decimal starts because it's a whole number. When I multiply, it goes to the right one time, and I get 50. 5 times 10 to the second power, I'm going to move it to the right 2 times. Here's proof. 10 times 10 is 100. I've got my 2 zeros. Same thing up here. Start with my decimal, move it 2 places to the right. I now have 500. Again to the right. 10 to the third power is 10 times 10 times 10, which is 1 with 3 zeros. So here's my 5. Starting decimal point, 3 times. 1, 2, 3. Ending decimal point, fill in my zeros. So 5 times 10 to the third power is 5,000. And same thing with here. 10 to the fourth power is a 1 with 4 zeros. Going to the right. By the way, I do always tell my kids when they see the signs, until they have this fully down pat, they really should put an arrow above. And the arrow represents when I move my decimal to the left, it decreases by tens. When I move my decimal to the right, it increases by tens. So again, I'm back down here. I apologize. Here's my decimal point right now. I'm going to move to the right 4 times. 1, 2, 3, 4. Ending decimal point. Put in my comma. 50,000. So again, it's very similar to what we see up here as our pattern. I moved to the right, and I increased by that number of zeros that was being multiplied. So let me just give you a couple of answers or a couple of examples. Let's say I have, because the decimal doesn't always have to be at the end of the number. Let's say I have 460 71 thousandths times 10 to the 5th power. Well, 10 to the 5th power means I've got a 1 with 5 zeros because it's 10 times 10 times 10 times 10 times 10. So it's a 1 with 1, 2, 3, 4, 5 zeros. Sorry. It's 100,000. So I'm going to take my 471 thousandths and I'm going to move my decimal to the right 5 times. 1, 2, 3, 4, 5. Here's my ending decimal. Fill in my zeros and I get 47,100. So it doesn't matter. The decimal does not have to be at the back of the number like we did here. Because here is at the back of that number. It was after the ones place every time. In this case, it's starting in front of the tenths place. It does not matter where it starts, as long as your child understands that when I'm multiplying, my number is increasing, so my decimal moves to the right, and the exponent tells me how many times. Or, same kind of situation. They might have, this still tells me, even if I have no exponent, the amount of zeros tell me how many times to move. 1, 2, 3, 4, 5. And if we were to do a division, let's say we've got 323 and 5 tenths times 10 to the 2nd power. I know this means 10 times 10, which is also being multiplied by 100. So all of these are the same. 10 to the 2nd power means this, and it also means 100. So I've got 2 tens being multiplied, 2 zeros here, and 2 here. I meant to divide, excuse me. So we're now looking at 323 and 5 tenths divided by 10 to the 2nd power. This symbol, I write my arrow, means my value is going to decrease, so my decimal will move to the left 2 times. 1, 2. So this is where it should end. That would mean my answer is going to be 3 and 23 hundredths. So that about covers it. One misconception real quick before this mini lesson is done. I've seen some kids move exactly right, but please make sure they move in between the values. Some kids will do this and go underneath the number, and then they don't know where it belongs. It really needs to go in between the digits. I hope that helps. If you have any questions, feel free to email me or send me a remind. Thank you.